Oh, good evening, guys. How are you? It's say TK, say Taku from Malanga. The last time we met, guys, we were looking at trig identities. Guys, how are you? Can somebody respond to show that you can hear me? Guys, can somebody respond to show that you can hear me? To indicate you can hear me?
We
All
are
right, I
good.
can see
Say how
that.
are you? We're here.
I'm okay. I'm okay. Thank you. Thank you. Thank you. Okay. Oh, sometimes I feel like I'm talking alone. Okay. So the last time, guys, we talked about trig identities, and I spent a lot of my time trying to explain how we prove certain identities. So today, I want us to get through um, a working with identities. So we are still looking at trig identities, right? So today, identities, right? So today, we are going to be solving uh, past exam, not actually past exam question papers, but those questions I took them from a textbook. Then after that, there's one question that I took from one past exam question paper. Then we're gonna end with that one. Okay. So, guys, the prior knowledge that we need, the prior knowledge we need uh, those trig identities. You remember the four identities that we talked about, right? The quotient identity, the square identity, the compound angle identity, and also the double angle identity, right? We need that knowledge. And another thing that is important, guys, is factorization. It's also very important. Then another one that is important is working with fractions. So we need the four trig IDs, the factorization, and also working with algebraic fractions. Okay. So guys, I want us to check our work and go straight to the first exercise, that is exercise number 7. All right. Exercise number 7, we had done number 1. So today I'll be enjoying myself working on these things and explaining to you. Guys, if you don't understand, feel free to speak out to say I didn't understand there. Then we can actually go back and look at that and try to explain further uh, so that at least all of us will be at the same page. Okay? So I'm going to jump. We did number 1. So I'm going to jump to A3. Okay? A3, which is saying sine of 2, that is 2 alpha minus 1 minus sine squared alpha is equals to 2 tan alpha, like that. Okay? So, like I explained last time, the equation has two sides. Equation has two sides of the equal sign. It has the left hand side and also the right hand side. Okay? So if you are given these, you have to check the complicated side is the one that you have to actually try to prove to be the same as the less complicated one. Okay? So we're going to choose, in this case, the left hand side. Okay? So the left hand side, our left hand side is equals to 2 sine alpha over 1 minus sine squared alpha. Sorry guys, it's sine 2 alpha. Okay? So the moment you see 2 alpha there, it means this one is what? It's double angle. Guys, even if you don't know how to work through, but the moment you see sine 2 alpha and know that it's a double angle, then you're going to get a mark for changing sine 2 alpha to its identity. Okay? So if we remember, sine 2 alpha is the same as 2 sine alpha cos alpha. Okay? Right? So we have used the double angle. We have used double angle ID. Okay? So in the denominator, guys, if you check, we want to get to tan here. And all of us, we know that tan from the quotient identity, tan is the same as sine alpha over cos alpha. So it is in our interest that the denominator is cos. But if we are checking here, we'll see that 1 minus sine squared alpha is the same as what? Cos squared alpha is the same as cos squared alpha. So 1 minus sine squared alpha is cos squared alpha. Okay? So from there we can see that, okay, we have cos alpha, we have cos squared alpha. If I want to extend it, I can actually write 2 sine alpha cos alpha over cos squared alpha is the same as cos alpha multiplied by what? Cos alpha. Then what's going to happen? We have common factors in the numerator and in the denominator, which is what? Cos alpha. Then this is going to cancel. What are we left with now? We are now left with 2 sine alpha over cos alpha. And we know that sine alpha over cos alpha is the same as what? Tan alpha. So this is 2 tan alpha. So what can we conclude? We have to conclude, right? We have worked the left-hand side such that it's the same as the right-hand side. Therefore, you have to conclude and indicate, therefore, the left-hand side is equals to the right-hand side. So we have to conclude that the left-hand side is the same as the left-hand side. Okay? So it means we have proved that this one is the same as that. Guys, on number 3, any questions? Any questions on number 3? Or silence means there are no questions. Okay?
Sir,
Right? Yes?
I wanted to ask, since the double angles were given from the formula sheet, how do we know that this one is the one that we should work with?
All right. You mean for cos, right?
Yes, sir.
All right. For cos, I'm getting there. I'm getting there for cos. Right.
Okay.
The one that the one we're actually working with there now is for sine. So sine, it doesn't have any other. It's actually 2 sine alpha cos alpha. It's unlike cos. Cos, remember that cos 2 alpha or cos 2a, it has 3 identities. So I'm still going to get there. Okay? Thank you. Thank you for the question. Right? So let's move on. Let's go to number 5. Let's go to number 5. We are still on exercise number 7, A5. A5. So what does it say? A5. Right? A5 is saying cos x over cos x minus sine x minus cos x over cos x plus sine x is equals to tan 2x. Okay, so if we check there, we have the left hand side and the right hand side. If we check which one is the most complicated one, it is the left hand side. So we have to work the left hand side until it is the same as the right hand side. I hope my space is going to be enough there because this one is going to be a bit long. Okay, so the reason why I told you that the prior knowledge that you need is working with fractions. Okay, I'm going to write a certain fraction there that I'm going to rub, a normal fraction, which says 2 over 3 minus a quarter, right? Work it out. How do we work it out? Remember, to work this one out, we need a common denominator. But for it to be easier for us to get the common denominator, what do? We multiply 3, multiply by what? 4. So we multiply this one, the denominators, we multiply them. Then, after that, we cross multiply. We cross multiply such that we are going to get on the numerator 2 multiplied by 4, then minus 1 multiplied by 3. Then as you are working it out, 2 by 4, you're going to get 8, negative 1 by 3, you're going to get negative 3 over 3 times 4 is 12. So your final answer, 8 minus 3, is going to be 5 over 12. Okay? So this is the knowledge of fractions. Working with fractions. If we are subtracting two fractions and the denominators are not the same, what do we do? To get the common denominator, you multiply this one times that one. Okay? That's the common denominator. Then we cross multiply with the denominators on the numerator. Okay? So now that is what we are going to apply even on our problem there. Okay? So I'm not going to write left hand side is equals to because of my space. So the left hand side is equals to, I'm going to start with the common denominator. What is going to be the common denominator there? The common denominator is going to be these ones multiplied. Okay? So this is going to be cos x minus sine x multiplied by cos x plus sine x. Then from there, I know that what am I going to do? I am going to do cross multiplication. Okay, so my cross multiplication is going to give me cos x into cos x plus sine x, then minus cos x into cos x minus sine x, like that. Okay, so I am going to expand the numerator, which is going to give me cos x times cos x. I'm going to get cos squared x. Cos x, I am going to get sine x cos x. Negative cos x times negative cos x, times cos x, we are going to get negative cos squared x. Then negative cos x multiplied by negative sine squared x. What am I going to get? I am going to get positive, right? That one is going to give me what? Sine x cos x over, if I can check in the bottom there, this is difference. This is from difference of two squares, guys. If you want to expand it, you can expand it. But this is from what? Difference of two squares. Cos x minus cos x, sine x. Then on the other bracket, we have cos x plus sine x. So this is from difference of two squares. So this is cos squared x minus sine squared x. Okay. Is there anyone who's vexed on this one? On the denominator? You can see that the expansion is from difference of 2 squares. Okay. Then, if we check on the numerator, we are going to see that cos squared x minus cos squared x, this one, they go. Because they're subtracting, right? They are like terms and they're subtracting, so they go. Then you are left with sine x cos x plus sine x cos x. So, better, when you are multiplying, start with sine x, then followed by cos x, always. So that at least it will be easier for you to see that these are like terms. Sometimes it will evade you if it is sine x cos x, then you have cos x sine x. But cos x sine x is the same as sine x cos x. That is what we call the commutative property of multiplication, where we say 2 times 4 the same as 4 times 2. So it doesn't matter which one starts when you're multiplying. Okay? So now these ones are like terms. Sine x cos x plus sine x cos x. It's a like term. Then it means we are going to get 2 sine x cos x over cos squared x minus sine squared x. Okay, so if you look from there, guys, we can see that from which identity do we get this one? Can I please have responses? From which identities do we get the numerator? Oh, guys.
From
2 sine x. Yes, from the double angle of what? Of cos or sine?
Sine.
Yes. 2 sine x cos x is the same as sine 2x over, how about cos squared x minus sine squared x? Where do we get it from? Remember, there's no plus there, there's minus. Where do we get this one?
From the double angle of cos.
Of course, that is the same as cos 2x. And guys, remember where we want to go? We want tan 2x. And now we are having sine 2x over cos 2x. And we know from the quotient identity, sine over cos gives us what? Tan 2x. Therefore, if we check, our left-hand side is now the same as what? The right-hand side. So we conclude. Therefore, the left-hand side is equals to the right-hand side. There we are. The left-hand side is equals to the right-hand side. Okay. So any questions, guys? On this one, I've illustrated how we work with fractions. So when you see fractions like that, don't be vexed and say, oh my God, oh, those things have come. It's just simple. You remember that fraction that I calculated. It is just the same as this one that I've just calculated now. The one that was having figures, and now the one that is having what? Cos x and sine x. They are almost the same. So just to know your multiplication. Okay? So if there are no questions, I am going to proceed and go to the next one. I'm going to look at 7 and also number 9 on these ones. Okay? So I'm wrapping that one. Guys, if you need to take a screenshot or something else, you can tell me, but remember that a video is going to be there available for you so that you can review and check how it is done. Okay? So now, if we check on number 7, we are having 2, oh, my phone is off. We are having 2 sine squared theta over 1 plus cos 2 theta is equals to tan squared theta. Okay? So again, like I said, we have the left-hand side and we have the right-hand side. Okay? So we have the left-hand side and also have the right-hand side. Okay, so on this one, I'm going to write the left-hand side. I hope my space is going to be enough. Left-hand side is equals to 2 sine squared theta over 1 plus cos 2 theta. Right, there we have cos 2 theta. I didn't check your name when you're saying you wanted to know when to use which one. Remember that cos 2 theta, it has 3 expansions, right? Cos 2 theta is equals to cos squared theta minus sine squared theta, which is also equals to 1 minus 2 then sine squared theta, which is also equals to 2 cos squared theta minus 1. So a person tends to wonder, which one am I going to use between 1, 2, and 3? All right. Now, check your right-hand side, the one that you want to prove. I want to prove tan squared theta. So, tan squared theta, if I'm having on the numerator sine squared theta, it means on the denominator, what do I want? I want cos squared theta. So I do not want anything that is having sine. I don't want the first two. I only want what? The last one. Because I don't want sine there. It is going to complicate my things. I want only what? Cos. Why? Because I know that tan squared theta is the same as sine squared theta over cos squared theta. Okay? So, obviously, I can't work well with sine. I don't want sine here. I don't want it. I want the one that is having cos only. Okay? So, what am I going to do? I am going to change, right, that my left-hand side. On the upper part, we are not going to change anything. Sine squared theta over 1 plus. But this one, cos 2 theta, I am now going to use 2 cos squared theta minus 1. Because I want to remain with cos in the what? In the denominator. Okay? So now I see I have 1 and minus 1 here. What's going to happen? Means these ones are going to cancel out. Right? So now I'm left with 2 sine squared theta over 2 cos squared theta. Remember that 1 minus 1 is equals to 0. Right? These are like terms, so we can actually arrange together like terms. So from there, what's going to happen to 2 and 2? 2 and 2, 2 into 2, they cancel. Okay? So now I'm left with sine squared theta over cos squared theta, which is going to give me what? Tan squared theta from the quotient identity. All right. So now I conclude, therefore, my left-hand side is equals to my right-hand side. That is how we do it. That is how we do it. Any questions there, guys? Silence means no questions. I'm going to move on to the last one there, number 9. A9. A9. Right? A9, what is it saying? It's saying cos 2x plus 1, right, over cos x is equals to 2 sine x over tan x. Right? Here, if we see there's a bit of a complication, what complication do we see? We have tan x there, which this one can be simplified, and also this one can be simplified. So let's start with the left-hand side because it seems like it is the most complicated one. Okay, so we have to go to the left hand side. Okay, so now the left hand side is equals to right. Now I don't know who asked, but I'm gonna ask. On the numerator, what we have there? We have psi. So which one are we going to use there? Which one are we going to use? Okay, we cannot use sine there. Why can't we use sine? Because we have a problem that if we have sine, we are going to actually end up having, because it's going to be 1 minus sine, which is we are going to end up having 2. We don't want 2. Right? If we check this side, we'll see one thing. What are we going to see? We are going to see that we are having sine x over cos x, that is tan. Okay, I'm going to come to that part of dividing with fractions, right? So here on top, I am going to choose, I would rather choose 2 cos squared x minus 1 plus 1 over cos x, right? That is simple for me, right? Then negative 1 plus 1, that is going to go. I'm going to be left with 2 cos squared x over cos x, right? Okay, that is that. Now let's see how we proceed. Remember that cos squared x is divisible by cos x. So what's going to happen here? What's going to happen is that cos x is going to go there and cancel the square. So that we are now left with what? 1 cos x. Okay, so now we are left with 2 cos x. Right, but as we check there, we can see that this is not the same as the right-hand side. So is there anything that we can do to the right-hand side? Yes, it is there. 2 sine x over tan x, which is the same as 2 sine x over sine x over cos x. Right. Guys, I want to tell you today that if you're dividing with fractions, you invert the divisor and change division into multiplication. So this is going to be 2 sine x multiplied by, then this one we are cooler. So it's going to be cos x over sine x. We call this one inverting and multiplying. Right? So this is going to give us, if we see there, we are going to do cross division there. So the cross division, sine x, goodbye. So we are now left with 2 times cos x. So we see that now we have 2 cos x, right? Then conclude, therefore, the right-hand side, the left-hand side is equals to the right-hand side. By comparing that part and also that part. Right? By comparing that part and also that part. So now you see that they are now the same. Right? Even if you had used the other expansion, I think you're also going to get to that one. Right? Let me try to use the other expansion there. Guys, if you're taking screenshots, you can take screenshots now before I wrap.
Sir, can you please explain the second step of the right-hand side?
This one.
Yes, sir.
All right, thank you. Who is speaking? I'm not looking at my phone right now. All right, Kuma. Okay. Right. Is it okay if I can explain it here? Right.
Yes, sir.
We can have 2 over 4 divided by half. Right? This is a fraction divided by what? A fraction. Right? So when you are dividing with a fraction, guys, if you remember your grade 8 very well and your 9 very well, it says if you are dividing with fractions, you have to change the division to multiplication. You invert the divisor. So inverting the divisor is actually doing this. Right. The denominator goes to the numerator, the numerator goes to the... Yes.
Sorry to interrupt, sir. So we are dividing that side that we're dividing. We are going to multiply with the reciprocal. Is that it?
Yes, yes. Thank you. So times 2 over 1. The reciprocal of half is what? Is 2 over 1. Right. Did you see that? Then 2 times 2?
Thank you, sir. I understand.
4 over 1. 4 over 4. So we are going to get 1. Right. Okay. So now what have we done? This is over 1. Okay. So we change this one. We invert the divisor and multiply. Okay. So that is it. So guys, if you're working with the other ways, it's also possible there. You can actually try the expansion of sine that says 1 minus 2 sine squared x. And you see, you actually manage to manipulate it until you get there. So you have to try on your own there, and you see that it's going to work. Okay? So that's the first one. Now let's go to number B. Number B, I'm going to start at number 2. Let's go. We are still on exercise 7, and we are at B. We are at B. B2. Right? B2 says, okay, it says tan A multiplied by sine 2A over 1 minus cos squared. It's 1 minus cos A is equals to 2 plus 2 cos A. All right. So how are we going to do that? This one is simple, guys, because we only have 2 steps. Whenever you see tan and we are dealing with identities, you have to change it. And also sine 2A, we know the expansion, guys. So I'm going to take the left-hand side. Is equals to, where there's tan A, I'm going to change tan A to sine A over cos A. Multiply by sine 2A, the expansion is 2 sine A cos A. Remember that this is over 1. Over 1 minus cos A. So here we can't do anything. So what are we going to do there? This one is simple. We are going to actually cross cancel because there's multiplication there and we have common factors. So this one and this one are going to go. So what are we left with? We are now left with sine A multiplied by 2 sine A, which is going to give us 2 sine squared A over 1 minus cos A. All right. But look where we want to go to. We want something that is having cos, but we are having sine. Okay? So this is going to lead us of where to go. So how am I going to go there? Sine 2A is the same as what? Guys, is there anyone who can tell me sine 2A? In terms of cos. What is sine 2A in terms of cos? Sine squared A, I mean.
Minus cos squared A.
It's 1 minus cos squared A. This is going to be 2, then in brackets, 1 minus cos squared A over 1 minus cos A. But guys, look, this one doesn't have a denominator, and we are still having a denominator. Is there anything that we can factorize on the numerator? Is there anything that 1 minus cos squared A, right? What is it? Yes. That is difference of what? 2 squares. This one is a perfect square. That one is what? Perfect square. So if we factorize that, we are going to have 2, then in brackets, that one is going to be the square root of this one, 1, the square root of that, cos A, then 1, right, 1 minus cos A, then 1 plus cos A, because this is the difference of 2 squares. That is a perfect square, that is a perfect square, that is a difference. So over 1 minus cos A. Is there anything that is going to cancel, guys? Any common factors?
1 minus cos A.
Yes.
Yeah. Yes. This one and this one. Bye-bye. So what are we left with? Now we are left with 2, then in brackets, 1 plus cos A. Then 2 times 1, it's 2. 2 times cos A plus 2 cos A. Then we can see that the left-hand side is equal to the right-hand side. So guys, what leads us of what to use is where we are going. What leads us of what to use is where we are going. Remember, I mentioned it yesterday that this can be factorized. So guys, if you are taking your screenshots, you can take the screenshots now. You can take the screenshots now. Okay, thank you. I'm now wrapping. All right. Okay. So guys, I want you to remember this. People, they forget that cos squared A plus sine squared A is equal to 1. Then this can be cos squared A is equal to 1 minus sine squared A. And this one is different of 2 squares, so it's 1 minus sine A, then 1 plus sine A. Okay? Then also, sine squared A is equal to 1 minus cos squared A. And this one is difference of 2 squares, which is 1 minus cos A, then 1 plus cos A. Okay? This is how it is. Right? So don't forget this. Right. Now I want to jump to number 3. Let me do number 3. Number B3 says cos alpha plus sine alpha over cos 2 alpha is equal to cos squared alpha plus sine squared alpha over cos alpha minus sine alpha. Right? Then from there, we can check what can we do. The right-hand side is equally complicated to the left-hand side. I love the left-hand side because it has 2 cos 2 alpha. So I'm going to choose the left-hand side, which is going to be cos alpha plus sine alpha over Right, cos 2 alpha. Right, if I see on my denominator there, I can check that I'm having cos alpha and minus sine alpha. So it means in the bottom there, I also have to choose something that is cos alpha and sine alpha. So what is it going to be? I am going to choose cos squared alpha minus sine squared alpha. That is the expansion that I have chosen on the bottom. Okay? So if I check now, there's nothing that I can do on the numerator, so I'm going to deal with the denominator. Right? Cos alpha plus sine alpha over, what can I do to the denominator, guys? What can I do to the denominator? Oh,
Open two brackets.
sorry? Yes, you can say it again.
Open two brackets in each.
Open two brackets.
Of the yes.
Yes. Open two brackets.
For each.
For each. Guys, just check. This is difference of two squares. Don't be vexed. This is difference of what? Two squares. There's no common factor there. That's a perfect square. That's a perfect square. Factorizing difference of two squares. Guys, we did that in primary. Was it primary? Oh, grade 8 and 9. Okay. So what's the square root of cos squared? It's cos x. Cos x. The square root of sine x, squared x, sine x, sine x. Then it's just a minus and a plus. That's difference of what? Two squares. Just to check, is this one a perfect square and is that one a perfect square? Do we have a minus? Yes. So we call it difference of two squares. I hope we know that, guys. Difference of two squares. Right? So, do we have a common denominator there? Yes. The common denominator, a common factor? Yes. That one and that one. Such that you are left with 1. You are saying cos x plus sine x into cos x plus sine x is 1. So now we are left with 1 over cos x minus sine x. Okay? Right, guys. Now, what do we do? I'm having 1 over cos x minus sine x there, and it's not the same as the right-hand side. Are they not the same or they are the same?
Yeah, the same.
Why?
Because cos squared alpha plus sine squared alpha is equals to 1.
Yes. Because cos squared alpha plus sine squared alpha. This one. Cos squared alpha plus sine squared alpha is equals to what? 1. So we know that 1 there on the numerator is the same as cos squared alpha plus sine squared alpha. Then over cos alpha. Was it alpha? Oh, I was using x. Right? Cos alpha minus sine alpha. Therefore, the left-hand side is equal to the right-hand side. Thank you for that. That 1 is the same as that. From the square identity, cos squared alpha plus sine squared alpha is equal to 1. From the square identity. Okay. Now let's move to the next. My time is moving very, very fast. So I am going to do number C1. I'm going to do C1 very fast. I'm going to do C1 very fast. Okay? So that I can move on. We looked at the double angle here so that I can also move on to the compound angle. Using compound angle. Okay? So C1 It says sine 4x is equals to 4 sine x cos x minus, it says sine 4x is equals to 4 sine x cos x minus 8 sine cubed x cos x. All right. Right. Now, obviously, the most complicated one is the right-hand side. But the right-hand side, how am I going to move there? Oh, it's going to be a bit difficult. Factor out sine x cos x. It's going to be somehow. So, I am preferring the left-hand side, which is equals to sine 4x. Okay? So, from my knowledge, sine 4x, it can be a double angle. How? It's going to be the same as sine 2 multiplied by 2x. Right? So on my expansion, I know that sine 2 multiplied by 2x is the same as 2 sine. The angle that I'm having there is not x, it's 2x. Then cos 2x. Okay? This one can be further expanded. Sine 2x is the same as 2 sine x cos x. Don't forget that this 2 was already there. We are expanding for that one. So this one is 2 sine x cos x. Right. Okay? Right. And cos 2x. Where do I want to go? Guys, just to check. Already I'm having 4 sine x cos x. I'm having this side. So I am going to use 1 minus 2 sine squared x on that side. Okay? Then on that one, 2 times that, we are going to get 4 sine x cos x, right, into 1 minus 2 sine squared x. Then 4 sine x cos x multiplied by 1, we have 4 sine x cos x. 4 sine x multiplied by negative 2 sine squared x, we are going to get negative 2 times 4 is negative 8. Sine x times sine squared x, sine cubed x, then cos multiplied by cos x. Then the left hand side is equals to the right hand side. Okay? Right. That is that. That is that. Right. So I am now going to move to exercise number 8, so that at least we can look at the compound angle identities. So that we can look at compound angle identities. Right. Let's go to exercise number 8. And we are going to start at A1, which is saying cos A plus B plus cos, that is A1, which is cos A plus B plus cos A minus B is equals to 2 cos A cos B. All right. So we see the complicated one is the left-hand side, which is going to give me cos A plus B. It's going to be long, guys. It is going to be cos A cos B. Then remember that this one changes to minus sine A sine B. Right. Then we have that one plus cos A cos B Then this one changes to plus sine A sine B. That one is not visible because, but this is sine A sine B. Right? Guys, we have like terms. The like terms are that one and that one. Right? Then also this one and this one. But look at this one. This one is minus sine A sine B plus sine A sine B. So this one, they are going to cancel because they are the same. So those ones that are not the same are going to add. So this one, cos A cos B plus cos A cos B, that is 2 cos A cos B. So now we see that the left hand side is cos to the right hand side. The left hand side is cos to the right hand side there. Okay? Right, that is that. I'm also going to go to number 3. I'm going to choose number 3. Right? Hey, this one is long. I hope it's going to fit on my board. A3. Okay? A3, it's saying cos x plus y minus sine x minus y over cos 2x is equals to cos y plus sine is equals to cos y plus sine y over cos x plus sine x. Right. So I'm going to still choose the left hand side, but I'm going to choose it actually working on it. Let's expand. This one is going to be cos of x cos of y minus sine of x sine of y. Then there we are going to have minus and put brackets. Sine is going to be secocos, which is going to be sine of x cos of y. Then the sign remains the same, minus my space there, it's not good. I don't want to squash things. So I'm saying the left hand side is equals to cos x cos y minus sine x sine y minus, then I put this one in brackets, which is going to be sine x cos y minus. Remember that this one, the sign remains the same, but that's cos x sine of y over. Now there I have a problem that this one, what am I having on the denominator? I'm having cos x and sine y. So I am going to actually expand in this manner, cos squared x minus sine squared x from the double angle. Okay? So because of my space, guys, I'm going to open brackets there and just multiply. That negative times positive, we get negative. Negative times positive, negative, we get positive. So I'm going to open my brackets there and write it in red. That one is going to be negative, and that one is going to be what? Positive on our multiplication. Right? Because I don't want to repeat this one. It's going to take my time. Okay? So now let's hunt for our like terms. What do we have there is our like terms. Do we have any like terms? You see that we do not have any like terms there. So we have cos x, cos y. Then that side, they are not the same. Guys, but from our grade 10, we know that when it's like that, we can actually factorize by taking out common factors, we actually separate them into two, then take common factor. So now, what is the common factor here? The common factor here is, or we can actually, not on that one, we can actually take what's common together. So I'm going to take cos x, cos y, then plus cos x sine y. Then these two, I am going to take them together, minus sine x sine y minus sine x cos y, right? Over, also in the denominator there, I told you that this is a difference of two squares, which is going to be cos x minus sine x, then cos x plus sine x, okay? Then on top there, I can take the common factor, right? What is the common factor there? The common factor is cos x. Yeah, I'm going to separate them. I'm going to separate them like that. What is the common factor? The common factor is cos x. If I take out cos x, I'm left with cos y plus sine y. What is the common factor there? It is negative sine x. So I take negative sine x, then I'm left with what? With sine y plus cos y, right? Over cos x minus sine x, then cos x plus sine x. Guys, if you check this one and this one, they are the same, because cos y plus sine y and sine y plus cos y is actually the same, right? So we have a common factor on top. What is the common factor? The common factor is cos y plus sine y, right? Then I'm going to have cos x minus sine x, right? So it's actually, it seems like it's coming from difference of what? Of two squares, cos. That is how it is. Over, then on bottom, we have cos x minus sine x. Then I have cos x plus sine x. So what is going to actually go? What is going to go is that one, and that one. They go, because they're the same. So I'm now left with cos y plus sine y over cos x plus sine x. Therefore, left-hand side is equals to right-hand side. I know many of you are lost, but if you follow after it, you actually see where we are coming from and where we are going. Okay? So that is that I want us to do. These ones I've left B. I wanted to also do number B, but I'm more interested. My time is gone now. I'm more interested in doing that past exam question paper, so that we can see that we can also apply this stuff in the past exam question papers. So the last worksheet that I sent, guys, it's from the past exam question paper. So I'm not going to do everything on that past exam question paper. I am actually going to do the last two. I'm going to do the last two on that one. Right? So what are the last two saying? The first one, 5.3, is talking about the general solution. But the general solution, we are having cos 4x, then cos x plus sine x multiplied by sine 4x is equals to negative 0.7. That is simple, guys. If you see this expansion, where did it come from? It comes from the compound angle identities. Where they've just tried to vex you is here. But if you know that there's a commutative property of multiplication, order does not matter. You can rewrite it. cos 4x cos x plus, start with sine 4x. Sine 4x, then sine x is equals to negative 0.7. Okay? This expansion, where does it come from, guys? It's been long, I've been speaking alone. Oh, am I speaking alone? Guys?
Angles.
From compound angle. And remember that we are having cocosine. Cocosine comes from cocosine comes from cos. Secocos comes from sine. So this one is the same as cos of 4x. Remember, if it is cos, the sign that is here, it actually changes. So it was plus, now it becomes what? Minus. Then the other angle that is there is x is equals to negative 0.7. So this is simply cos of 3x is equals to negative 0.7. We did general solution, guys. From there, you know what to do. Now, you go cast. Where do we get cos negative? Here and there. Then get your reference angle, then work it out. But remember that here we don't have x. We have what? 3x. We don't have x, we have 3x. So work it out. From there, guys, you get your answer. You get your solution. All right? So any questions on that? I hope not. Okay. The last one is 5.4. The last one is 5.4, which is actually saying prove the identity sine 4x cos 2x minus 2 cos of 4x sine x cos x over, let me rewrite it again because my space, which is saying sine of 4x multiplied by cos of 2x minus 2 cos 4x multiplied by sine x cos x over tan 2x is equals to cos squared x minus sine squared x. Wonderful. The people who said these things, they want to be clever for nothing. They want to be clever for nothing. I want to tell you this. Because now, guys, check. We have seco, but here we have cos, then we have 2x cos 2 cos 4x sin x cos x. So they want to be clever because these things are not arranged. But if they were arranged, then it was easier for you. So this is going to be sine 4x. I've chosen already the left-hand side. Cos 2x. Do not expand when it's like this. You can actually see that it's seco. So what I'm left with cos. Seco. So cos. I want cos. How can I get it? Minus. Let me start with cos of 4x because I know that it is going to be cosy. But if I check, if I start with cos 2x, remember this is multiplication in order, doesn't matter. So this is going to be multiplied by 2 sine x cos x over down there, tan x is the same as sine 2x over cos 2x. Right? But if we actually check on the letter, guys, on this one, on this part that I'm actually underlining in black, 2 sine x cos x. It's from a what? it is from a double angle. It is from a double angle. So what does it mean? It means simply, this is going to be sine 4x cos 2x minus cos 4x. And that one is from what? That is from sine. So this is going to be sine 2x over sine x, sine 2x over cos of 2x. That is time. So guys, seco cosi, seco cosi, seco cosi is from sine. Coco cc is from cos. Seco cosi, it's funny. Seco cosi, seco cosi, then coco cc, coco cc, seco cosi, seco cosi, coco cc. Okay, so this is actually not interesting, right? So it means this one is from side, and remember that the angles are the same, both sides. So this is going to be sine. We start with the first angle, 4x. Then here we have minus, sine is the same sign, minus 2x over sine 2x over cos 2x. Okay, so what's going to happen there? Let me write this side. That is going to give us sine 2x, because 4x minus 2x is 2x over, okay, over 1 multiplied by, I'm going to do that one. That one says, let's use the word reciprocal. It's fine. Sine 2x over 1. That is that one. Multiplied by this one. Then it becomes what? Cos 2x over sine 2x. Okay. So what's going to happen here? Cross division. Gone. Gone. So what are we left with? Now we are left with cos 2x. And we know that value cos 2x is the same as that part. Cos squared x minus sine squared x. Therefore, left-hand side is right-hand side. Okay? So, guys, don't be vexed by these people. They try to hide these things from you so that you won't see. But just know that, okay, if I'm starting with seco, then I need cosi. If I'm starting with coco, then I need cc. So you see how you manipulate the other part. Or maybe it can start with something else here, then it says cc. Then it means you have to manipulate this side until it comes to what you want. Guys, those are trig identities. I've tried to cover a lot. Any questions, guys? No. Silence means confusion, or maybe you are covered. All right. Thank you very much, guys, for attending the lesson. I now conclude my lesson now. Yes? Is it Alan-san? Oh, I'm not getting you. I'm not getting what you're saying.
Yes, Mr.
Yes.
I need to the second last stage.
This one? Or that one?
Yes. Where does the cos no to the cos 2x?
This one?
Down. Yes. Where does it come from? Because you wrote sine 4x minus 2x.
This one. All right. So,
Yes.
I jumped some stages there because of my space, but it's fine for you. Let me actually do everything. I jumped some stages there because of my space. Okay. So I am going to try rub there and try to squeeze it. Okay. That is sine 2x over cos 2x. Okay. Right. Up to this part, Do you understand sine? Sine 4x minus 2x. You get this one, right?
Yes.
Over sine 2x over cos 2x. Okay? So the next step was supposed to be sine 4x minus 2x, that is 2x. Still over sine 2x over cos 2x. Then remember, we discussed this one earlier. To say when you are dividing with fractions, what do? We actually invert the divisor and multiply, right? So that is what I did. That is sine 2x, the numerator, right? This is over 1, right? Then multiply by, now we take the reciprocal for this one. When you change division sign into multiplication, we have to take the reciprocal of that one, which is going to be cos 2x over sine 2x. That is where we got it from, right? Such that this one cancels with that. Okay? Then from there, what are we left with? Yes, we are now left with cos 2x. And cos 2x, we know where we want to go. We want to go here. It's the same as cos squared x minus sine squared x. Therefore, left-hand side is equal to right-hand side. Are you covered now?
Thank you, sir.
All right. All right. Thank you guys for attending. I hope this lesson was fruitful. And guys, I want to leave you with this. Guys, trigonometry, the moment you close your books and says, I'm done with, say, I think I understand, that is the moment everything's going to vanish. Mathematics is a doing subject. You have to do mathematics every day. Put whatever that we have done into practice. If it is possible, check it through the video, then try to take the questions on your own. Start with what we have done. Try to work through them until you understand them. And you'll be checking with the video. Then, if you understand them, that is where you go to the next ones. Guys, maths is a doing subject. Once you sit down and fold your hands and say, I'll see it in the examination is going to surprise you, and you're going to get more and more confused. So please, as I'm closing now, you're going to rest and do it. Thank you. I understand you are going to other subjects, but it's fine afterwards, maybe tomorrow or another day. Okay, thank you very much. So don't forget, guys, to comment with any word that you got from the lesson. And I want you to comment with Cocosis and Sikokos today, because it's something that is fun, something that actually we say so that you can remember, guys. Okay, thank you very much. Until we meet again, you have a wonderful week. Goodbye. Hi.